Hey, what's up, guys? Welcome to another episode of Some Good Science, coming to you kind of live from the other side of my kitchen table. All right, so this has to do with our next part of our climate unit, and we're going to talk about the sun's energy and climate change as well. Now, I know you all saw the video from a couple of weeks ago, the documentary with Leonardo DiCaprio, and we'll kind of point out some pictures, before and after pictures as well, too. All right, so first of all, the sun's energy. As you can see here in the graph below, the wavelength of energy the Earth receives in the greatest amount, the greatest percentage reaching the Earth's surface, you could see here, is mostly visible light, right? A little bit of ultraviolet and a little bit of infrared. And this might look familiar to you also because this is similar to the electromagnetic spectrum that we talked about a while back. Okay? The shorter wavelengths versus the longer wavelengths. The primary gas which absorbs ultraviolet light from the sun is ozone. This gas gets absorbed in the stratosphere. And the three primary gases which absorbs infrared energy is carbon dioxide, water, methane. I'm sorry, my dog is like trying to get my attention right now, so I'm a little distracted. The three primary gases which absorbs infrared energy is carbon dioxide, methane, and water vapor. Methane, you might know, why is there a picture of a cow? Because it is known as the farting gas. And these are all heat-loving gases too. So they love to absorb heat and they love to give it back. And I have some videos up this week that talks about methane and hunting for methane. It's highly flammable, is definitely more potent of a greenhouse gas than carbon dioxide. So I think you'll find that interesting this week. Okay, so why is the ozone layer important? Well, the ozone gas gets absorbed in the stratosphere. Excuse me, the ultraviolet rays from the sun get absorbed by the ozone in the stratosphere. And that's important because it protects the Earth from ultraviolet rays damaging crops and causing cancer in humans. Years ago, when I was a kid, and there's a video at the end of this note, at the end of these notes that you could check out, that talked about how there was a hole in the ozone layer that was created from using hairsprays and aerosol cans and things like that. And it went ahead and broke down the ozone gas in that layer and started to create a visible hole. And there was a lot of concerns with that. So there was some changes in some product designs which cut that down, and they're definitely seeing better effects from some changes that were made. So why is it warmer on a cloudy night than on a clear night? So what happens is we have clouds, they trap infrared energy from the Earth. So as the sun beams down on the Earth's surface, will warm up, especially during the day. And if it's cloud and the heat energy or the infrared energy will start to, trickle upwards. But if the clouds are on top, it's kind of like a blanket and it's trapping in that heat energy. But if you remove those clouds, then the heat is able to escape back into space. So the reason why I have this picture up is because I like to introduce this to you before I start talking about the greenhouse effect. So the greenhouse effect is an analogy that is used to describe how our Earth's atmosphere is able to stay warm, just warm enough to support life. So first I want you to think about, because everybody has, a lot of people have greenhouses, but a lot of people have cars, and you experience the same thing in your car all the time. So as the sun's energy passes through the car's windshield, it's able to penetrate, especially the ultraviolet rays, because remember, they're very short wavelengths, and so they're able to cut through things a lot easier than something that's longer. And it goes through the windshield of a car. Then the seat cushions of the car and the whole car's interior will absorb the ultraviolet rays and convert them into longer wavelengths. So it slows down that ultraviolet energy as it gets absorbed, and therefore creating a longer wavelength and making transforming it into infrared energy or heat energy. And if the car windows are rolled up, inside the car gets very, very hot. once you roll down the windows, then the heat is able to escape. So it's kind of similar to what we were saying over here too. The clouds trap in the heat energy that the Earth's surface is giving off. Okay. Now let's tie this all in together with the greenhouse effect and how this explains why our atmosphere is able to stay warm. So, and just to show you a picture too about a greenhouse, if you haven't seen one, some of them are scattered throughout the eastern part of Long Island. You see that right there. A lot of people use them in the wintertime too to keep the plants warm during the winter months, which is going to feel like that here in the next couple of days, unfortunately. Let's go back here. Okay, so ultraviolet rays go through the glass panes of a greenhouse, and then they get converted into infrared energy, increasing the temperatures inside the greenhouse. The infrared energy is too long of a wavelength to be able to go out or escape through the glass panes, so that's why it gets trapped. And like I said, causes the inside of the greenhouse to stay warm. Okay. Here's another example here where the greenhouse again, right? And the gases in the atmosphere, especially the carbon dioxide, absorb and re-radiate infrared energy. So just like the glass panes of a greenhouse or the windshield of a car, the ultraviolet rays pass through the transparent atmosphere, and some of it gets scattered off, the tops of like thick clouds or ice or snow-covered surfaces. But if it's able to get through the clouds or on a clear day, the ultraviolet energy reaches the Earth's surface, and the Earth's surface will absorb the sun's energy. And remember, the Earth can't create or give off ultraviolet energy, only infrared energy, because the Earth is not able to produce the kind of energy like the sun is. So the infrared energy is trapped in the atmosphere of our planet, and the greenhouse gases will absorb it as well and give back the heat too, therefore creating it at a warm enough temperature to sustain life. Okay. But sometimes when you add, like we were saying, a couple weeks ago, like you saw, what then is climate change? Okay, well, first of all, here's a good link too, if you want to check this out, why humans are so bad at thinking about climate change. And so kind of gives you an idea. It has to do with behavioral thinking. So check that out. Some climate change is a natural process, and this is a timeline. This has been recorded. You could see that from 200,000 years ago, the temperature has cooled down, has warmed up naturally, cooled down, and then warmed up. So we've had like some mini ice ages. And it's a natural process, but it takes like a really long time for those changes to occur. The thing is like lately, it's been just happening, over the past hundreds of years, it's been increasing, and particularly since the last industrial ice age. So ice ages, the cyclical warming is natural. The last one occurred around 12,000 years ago, and the exact causes of these triggers of an ice age are not known. Some climate change occurrences are normal, such as a couple of phenomena called El Nino and La Nina. El Nino is a warming of the Pacific Ocean. This is North America, this is South America, and these are the west coasts of those continents. You could see that this red blob right here is the middle of the Pacific Ocean. Now, if you remember that we have the California current, it is a cold current, and the Peru current, which runs past Peru. Then they come from the poles. A lot of fish in those areas depend on those cold waters. You can see here that this is a big red blob, so it's warmer than usual. What causes that exactly is not quite known yet. They're still studying that. El Nino is a warming of the Pacific Ocean, so it changes the climate of these regions. The West will be a little bit stormier. Actually, some years stormier than others. In 1997, I remember I was living there, and there was if the water is warmer, you're going to get more condensation. You're going to get more stormy clouds, therefore greater precipitation. Usually, California is a dry, arid climate. So in 1997, I remember I was student teaching first graders, and the campuses in California are all outside. So when they had to go to lunch, they would have to walk outside. And I just remember it was like the sky was just opening up and pouring rain, and the kids were so excited that there was so much rain out there. And they're like, Miss A, is this El Nino? Because in California, it's such a newsworthy event that it's going to rain. And so the little kids had heard about it all over the news. And so they were excited to see it raining cats and dogs outside. But other areas, the climate will change. In the south, it'll be cold and wet instead of, warm. And the Northeast, actually, like in New York, I remember when I was living in California, I would call up my sister in New York and be like, you talk about the weather and stuff. And I'm like, oh, how's the winter going? Have you gotten a lot of snow? She goes, no, actually, it's been kind of warm. We haven't gotten a lot of snow lately. And again, that was back in 1997. And if you want to know where the name El Nino came from, basically the fishermen off the west coast of South America, they were the first to notice the appearance of unusually warm waters that occurs at the year's end. And this phenomenon became known as El Nino because of the tendency that it occurred around Christmas time. El Nino is Spanish for the boy child and is named after the baby Jesus. So if El Nino means the boy child, then you know that La Nina means, that's right, the girl child. And so it's not a warming of the Pacific Ocean, it is a cooling of the Pacific Ocean. But actually, if I can go back here for a second, I just kind of want to show you if you can notice it. This is, yeah, right in the middle. This is normal conditions along the Pacific Ocean. Of course, the water along the Pacific Ocean should be warm near the equator, but you could see down here that it's a little bit warmer than usual. You see more red. And over here is a La Nina condition where it's a little bit, where it's not as red. And so if I could show you that over here. We're back here. We are back here along the west coast of North America. And says a very strong La Nina is pictured on the left, and a weak La Nina event can be seen on the right. So I told you that the last El Nino was 1997. So in 1998, things definitely started to cool down. And in 1999, things cooled down even more, changing again the climate of those regions. So it became dry in the southeast and cool and wet in the northwest. So definitely got colder there. What else I got? Oh, speaking of climate, you guys remember this picture too? Okay, what we'll talk about is how humans can affect climate around the planet, locally as well as around the planet. And if you remember me showing you this back in January, how in January of this year in China, you could see here that there was a lot of pollution in the atmosphere. And then once there was a shutdown in China, that the atmosphere became a lot clearer, a lot cleaner, and it was measurable. And so they're seeing that since then. There's been, examples of that in other cities as well too. Here you can see climate changes and carbon emissions from the biggest giant emitters are the United States, China, and in second place you could see here is Russia and some other countries too. And the reason why we bring that up is because if you're using a lot of energy, you're using a lot of fossil fuels. Fossils have carbon in them, you burn them, because all living things have carbon, and if you burn them, you're going to give off carbon dioxide. Carbon dioxide likes to take in heat from the Earth's surface or from anything that's given off heat and likes to give it back. So I have some videos too that I gave you guys that will show that as well. Okay. Oh, this is just kind of showing you how you have global temperatures in blue, and the carbon dioxide is in red, and taken from two different areas, showing how carbon dioxide has risen over the years. Okay, and you could see that the global temperatures has started down here, even though it kind of goes up and down and up and down. You could see it definitely has increased since 1880. Okay, so global warming, we call it more climate change, but they are seeing that temperatures around the planet have been rising, and it's been measurable. So global temperatures are increasing. Your glaciers then are melting, and if they're melting off of continents, then that water gets added to the ocean and causes sea levels to rise and causes flooding. We saw examples of that too in Miami from the video a couple weeks ago. Warming is natural, but if humans are speeding up the process by burning fossil fuels, then that becomes a global concern. Let's give you an idea. It's observable as well as measurable in 1928. You can see that this is the same location. This is the peak of that mountain right there, right? And so this is all glacial water now, and it's a lake. It's a pristine blue and melted from the temperatures rising and causing that glacier to melt. This is Greenland before and after on a 10-year period. Oh, you could see, here's another one too if I was in class. In 2004, in McCarthy, Alaska, this is the edge of the glacier, and this is, you know, the lake that it produced, because this is the end of it, and most of it is gone. This one over here too, in 1941, it goes all the way up there, and now you could see that is the end of the glacier there in 2004. And so you could see here since 1970, you could see where the glaciers have melted, the locations where the glaciers have melted the most and at the fastest rate. And I'll end this with a couple of things. This one was given to me by a former student, Amani Sharif. She was called Jasmine by her friends, and she shared this with me, and I always share this every year. And she found this, and it says, the Earth is 4.6 billion years old. Let's scale that down to 46 years. So that means we have been here for 4 hours. Our industrial revolution then began only a minute ago. And in that time, we have destroyed more than 50% of the world's forests. Something to think about. And the last video I want to leave you with is this one that was shared with me about 4 years ago. Andrew Friedman, he is graduating this year. Big shout out to him. And I love sharing this video every year. It is from, this link is not working, but you could find it. And I think I actually showed it to you during the week of Earth Day. So it is from the American Museum of Natural History. And so it kind of just shows you the changes that have been made since the first Earth Day in 1970. So some of the things that have happened and some of the improvements that we've made over the years. Okay, so check that out when you get a chance to, okay? So that's it for this week. Peace out. We love you. We'll see you next week.